Okay guys, today we're going to deal with solving radical equations. So basically equations that have radicals in them. Okay, so when we're solving kind of our steps, if there's one square root, we need to get it by itself. If there's two square roots, we got to get them on opposite sides of an equal sign. Then once we do that, we're going to get rid of the square roots by squaring both sides. Then we'll just solve for x. There's different ways we might have to solve for x, but then last we'll check our answer for extraneous solutions. Because the big thing with square roots is we can't do square roots of negatives, and we also know square roots don't equal negative numbers, so you have to be careful and check to make sure that your answers actually work out. Now let's look at this first example. So it has one square root, so the first thing I need to do is get the square root by itself. So I'm going to add 2 to both sides. Okay, so then I have the square root of x minus 3 equals 5 plus 2 is 7. Okay, now I'm going to go ahead and get rid of the square roots. How to undo a square root is a square both sides. Okay, so these simplify, so I just get x minus 3 equals 7 squared is just 49. Okay, now we're going to go ahead and solve for x. So add 3 to both sides. So x equals 52. Now I'm going to go ahead and plug that back in, okay, to the original. That means we're going to have the square root of 52 minus 3, and then minus 2 equals 5. We want the left side to equal the right side, so 52 minus 3 is 49. Well, the square root of 49 is just 7, so 7 minus 2 equals 5. And we already can kind of see that it's going to be 5 equals 5. So it does work out. This is true. So this is our solution. X equals 52. Okay, this example is kind of similar to the last one. We're going to go ahead and get the square root by itself. Okay, so I'm going to subtract 5 from both sides. So I'm left with the square root of x plus 3 equals negative 4. Now undo a square root, we have to square both sides. Okay, and the big mistake people make is they forget to square the right side. So make sure you do it to both sides. Okay, so x plus 3 equals 16. Okay, because negative 4 times negative 4 is positive 16. Minus 3 to both sides, so x equals 13. Now we're going to plug it in to make sure that it is not an extraneous solution. So we have the square root of 13 plus 3, okay, plus 5, and we're going to see if this equals 1. So 13 plus 3 is 16, square root of 16. Okay, square root of 16 is going to be 4, so 4 plus 5 equals 1. Well, no, that's 9, and we know 9 does not equal 1, so this does not work out. So this is actually an extraneous solution. So this is actually not going to work, and we're just, since we don't have a solution, we're going to put no solution. So that's why it's important sometimes to plug it in, because if it's an extraneous solution, that means it is not going to work out with the square root, so it is going to end up having your answer be no solution. Now sometimes they will give us 2 square roots, and if they do that, we got to get them on opposite sides of the equal sign. So we're going to go ahead and add this whole thing to both sides, this w plus 11, square root of w plus 11. Okay. Now this is going to simplify this side, so then we just end up having square root of 4w plus 2 equals the square root of w plus 11. Now once you get it to have them on opposite sides, we're going to square both sides. And when we do that, they just cancel out right there. So then we're just left with 4w plus 2 equals w plus 11. Okay. Now we can go ahead and just solve for w. So I'm going to subtract w from both sides. So I have 3w plus 2 equals 11. Subtract 2. So 3w equals 9. So w is going to be 3. Okay. Now once I have that, I'm going to go ahead and plug that in to check to see if it's extraneous. So if I plug it in, I'm going to have the square root of 4 times 3 plus 2 minus the square root of 3 plus 11. And then we're going to see if that equals 0. So let's go ahead and do that. Well, that's 12 plus 2, which is 14. So that's the square root of 14 minus the square root of 14 equals 0. Well, square root of 14 minus square root of 14 is 0, so 0 does equal 0. So this actually does work out. Okay, so my answer is W equals 3. Okay, so this one's similar to the last one. First thing we need to do is move this over to the other side so we have square roots on opposite sides of the equal sign. So if I add that to both sides, I'm going to go ahead and have square root of negative 2x minus 1 equals, and the other one's going to be on the other side, negative 3x plus 4. Okay, now I'm going to go ahead and square both sides to get rid of those square roots. So then we're left with negative 2x minus 1 equals negative 3x plus 4. We're going to solve for x now. Add 3x to both sides. So I have x minus 1 equals 4. Add 1 to both sides, so x equals 5. Okay. Now I'm going to go ahead and plug that back in and make sure these aren't extraneous. So I'm going to plug it into the top where I have the square root of negative 2 times 5 minus 1, okay, minus the square root of negative 3 times 5 plus 4 equals 0. Okay, well, negative 2 times 5 is negative 10, minus 1 is negative 11. Now I'm going to just stop right there. If we look at this, okay, I have the square root of a negative 11. Remember, anytime I square root a negative, it's imaginary. So that cannot be a real solution. So right away, once I see that, I know that x equals 5. We know that that's not going to work. So this is going to be no solution. Okay, the reason why it's no solution is when I plug it in, I have a square root of a negative, which we know is a no-no when we're talking about real solutions. Okay, so when we're doing this last problem, I'm going to kind of set up, if you notice the square root's by itself, so I'm going to have to just square both sides. So when I do that, I get rid of this, okay, so I end up having 7x plus 30 equals x squared. Okay, now when I notice I have an x squared, right away we have to realize, hey, the only way I can solve for a quadratic or something with an x squared is by like quadratic formula or factoring. For these ones, factoring is going to be kind of the quick and easiest way to do that. So what I'm going to go ahead and do is I'm going to go ahead and move everything over to one side. So I'm going to subtract 7x and subtract 30 to move everything to one side. So I set it equal to 0. So I have x squared minus 7x minus 30 equals 0. And now we're going to go ahead and factor this. When I factor it, what multiplies the negative 30 but adds up to 7? Well, negative 10 and positive 7. Or sorry, positive 3. That'll add up to a negative 7. So x minus 10, x plus 3. Okay. Now, I have to solve for x, so I'm going to set both of these equal to 0. So that means this is going to be x equals 10 and x equals negative 3. Okay. Now let's go ahead and take a look. When I plug these back in, okay, I'm going to give myself some space over here. Okay, and do this in a different color. When I plug these back in, okay, so we have the square root of 7 times 10 plus 30, and we're hoping that that equals 10. Well, 7 times 10 is 70, plus 30 is 100, so the square root of 100, does that equal 10? Well, it does. 10 does equal 10, so that does work out. So we know that this one works out, so I'm going to go ahead and box that one in since it works. Now let's try the next one. Okay, so that's square root of 7 times negative 3 plus 30. And we're going to hope that that equals, I'm still plugging this in for both of these x's. Okay, so that's why it's got to equal not 10, but it's going to equal negative 3 for this one. Okay, so that's going to be negative 21 plus 30. Well, that's 9. So that's going to be the square root of 9. And we want it to equal negative 3. Well, square root of 9 is just a positive 3. So it does not equal that. So that's a no-go. So this is actually going to not work out, this bottom one. So this one is not one of our solutions. And notice how I just put an X through it, telling me that, hey, that does not work out. That was an extraneous solution. Okay, so my answer is just this x equals 10. We have to check our answer because sometimes we get the correct answer, but then when you plug it back in, it does not work, which is an extraneous solution. The reason because of this is when we're dealing with radicals, we know that we can't do square roots of negatives, and we also know that square roots can't equal negative numbers. So it kind of limits what our answers can actually be.